Assalamu alaikum dear friends, so welcome to my new lecture on hope you all well and healthy. Today I want to solve and calculate this problem which you all see in this board. So let's start. Here is a problem how we can draw and calculate shear and bending moment diagram. So it's easy and have just some steps, so we should follow that. Here's the simple supported beam under 8 kN uniform distributed load. So we have one, so it's a simple supported beam, so it has one roller and one pin support. So first we should change this distributed load to pointed load. Okay, pointed load. So how we can? It's easy. If it's the middle point of this beam, so P is equal to W and L. W and L is this pin. 8 and 3 equal to 24. So our P is 24. At this step we should calculate this beam reactions and reaction and supports restraints. Okay, so I want to start from this place. Here is I start from step by step. Okay friends, and step 1, supports. Okay, supports and reaction. So this is roller support, this has just one reaction, and this is pin support, this has two reaction, but here we haven't unloaded in X direction, so I don't want to give that reaction. Okay, because that is 0. So if you want to calculate reaction, and if you want to find reaction in VB or in VA, so you if you want to find VB, so you should take moment to this point VA. Okay, so I want to find VB, so how we can do it? I want to find VB, so I want to take moment to VA. Here I want to explain summation moment at A point equal to 0. Our direction of moment is like this, positive. Okay, positive. So if we take moment to this point is, so we will have moment like this, negative to our moment. So VB is negative. VB negative, our spin is 3 meter, dot 3 meter. And here we have pointed load. Pointed load, this distance is 105 meter. Okay, because this pointed load is the middle of this beam. So its direction is to clockwise to our direction. So P is positive. I mean positive. That's 24 in 1.5 equal to 0. Why 0? Because we haven't any load to this beam till we right here. So we should calculate VB. VB is equal to, I think it's 12 kilonewton. Our VB is 12 kilonewton reaction have there, and 12 kilonewton reaction. So we find this VB reaction. So how we can find VA reaction? When we look to this beam have from A to B, and firm load, and in the every part of every distance of this beam all load is equal. So here VA and VB are equal. So I want to write here VA is also 6 kilonewton. Okay dears, we also have a short formula for this. VA and VB, they both are equal. WL divided by 2. From this formula we can find these two reaction. So we can calculate this two reaction. What we do in second step? The second step, I want to find shear force. How we can find shear force? Step 2, we have here step 2. step 2. In step 2, I want to find shear force. Shear force. How we can find shear force along a beam? So it's easy, and we should take a section where we want to find the shear force. We should take a section in different parts of beam when we have a pointed load and distributed load in one time on a beam. So we should take a section and 2 pointed loads for shear force. So I want to take in this beam section here for calculating this part. Okay, friends, A and A bar. So if you want to calculate shear force along this beam, so you can calculate in this part of beam and you can calculate in this part. They both are have same answer. So I draw this section here. I want to draw this section here. There is 12 kilonewton. This direction is 12 kilonewton, and this is our friend, and this is our V shear force direction. Here we have X, because we don't know this distance, but X interval is from 0 to 3. Here we also have distributed load there, 8 kilonewton per meter. So let's calculate shear force. I want to calculate here. Okay, so when we want to calculate shear force, we should do 0 along Y axis all force. So I want to do 0 H. Fy equal to 0. This is our direction. Up is positive and down is negative. So here we have shear force up is negative. We have 12 kilonewton reaction. That's positive because this direction is up. 12 kilonewton, and we have distributed load. Distributed load, we should change it to pointed load. That's also negative because this direction is down. 8 kilonewton and X equal to 0. We should find here V shear force 12 minus 8x, and this is our shear force equation. One equation. So how we can find some value of diagrams from this equation? It's easy. We said here X can take in this interval this 2 value. If here X equal to 0, so shear force take this value 12 minus 8 and 0. So shear force here is equal to just 12 kilonewton. So this is our V0. If X take this 3 value, so V, our shear force, is equal to 12 minus 8 and 3. So our V3 is equal to 12 minus 8 and 3, 24 and minus 12 kilonewton. So this is our shear force. So let's draw shear force diagram, and also we have in this beam that place where shear force equal to 0. So how we can find that? That place has 2s. So I will show in here. Here we have this diagram. Okay. In 0 we have 12 kilonewton shear force, that is this part. Okay, 12 kilonewton, and entry we have minus negative 12 kilonewton. Okay friends, minus 12 kilonewton. So let's draw this diagram, distributed load half shear diagram, linear diagram. Okay dear friends, so let's draw it. Okay, this is our shear force diagram. 12 kilonewton minus 12 kilonewton, because it's distributed along all beam as uniform and equal. So I can write like this. This is minus and this is negative 4, because this is down from 0 axis. Okay, as a shear force diagram. So how we can draw bending moment diagram? That's also easy, and we can take a section in a different part of a beam and calculate that's bending moment. So let's start. I want to erase this part because we should calculate here bending moment. Our shear force question was okay. I want to write here shear force. Our shear force equation is V equal to 290 minus 8 x. It's our shear force equation. So let's find bending moment. Step 4 at step 3, step 2 at step 3. At step 3. Bending moment. Okay, that's bending moment. So I wanna also find bending moment in this section, and it's same if you wanna find moment in this section or different part of this section, that's equal. Or because here load is uniform and equal in all part of this beam. If it's not, we should take bending moment in different part of the and different pointed load and different distributed load until we find pure bending moment. So let's draw this section. I will give direction like this bending moment, and this is uniform load 8 kilonewton per meter, and also here we have this x, and x half of this interval from 0 to 3. Okay dear friends, and this is the reaction is 12 kilonewton. 12 kilonewton. So let's find bending moment and draw test diagram. It's easy, and we will find it. So let's I show, if you want to find moment in this section, you should take from one point moment. I want to take moment to this point. So let's m at point equal to 0. Our direction is like this, positive. Okay friends, so it's positive for our direction, and this direction of moment is not equal because this opposite of this direction, so that's negative. M minus x, and this reaction direction equal to this our direction, so that's positive 12 and x this x distance, and we have a uniform load also, that's direction minus negative 8 in x by divided by 2, x divided by 2 at this distance. Okay friends, and equal to 0. We should find m. We should solve this equation for m. So that's 12 x minus 4x square. And this is the bending moment equation from which we can draw bending moment diagram and also find max moment. How we can find max moment, that's also easy, and we can find from this equation. Just we should find x for x max. How we can that? So let's first find m0 and m3 for this solution. If x equal to 0, so our m is also equal to 0. If x equal to 3, our m is also, and this for tossor, because simple support beam and roller support and pin support can't bear moment. Inshallah you are interested. Okay, so here we have two value, so we should find also max moment. So how we can find max moment? We should find max moment for first we should find this distance in where x bending moment is equal to 0, in which place in long of the shear force equal to 0, in that place we have max bending moment. Okay, so let's find this place. How we can find this? We should take it 0 and take out this x value. So let's do it. I wanna use this marker here, 12 and this x equal to 0. So find this x value, 12 divided by 8, and it's equal to x 1.5. Okay friends, so we should replace this x in this equation till we find mm max. So let's find mm max. So max 12 1.5 and minus 4 1.5 square. Let's find is here because we haven't seen a place of MA max. M max also equal, I think it's 5.04 or something else. So that's at 5. If you calculate this equation, so we discover this value. So let's draw bending moment diagrams. How we can bending moment diagram, draw bending moment? We have two value and 0 in x take a value of 0, so a bending moment is 0. So when x take 3 values, bending moment is also 0, and we have max moment, that is 5. Okay, 5.04. 5.04. So let's draw bending moment diagram. This is our bending moment diagram. Positive moment, okay, this is positive bending moment diagram, and here I also give it, it's A, it's B, it is SFD diagram, and this is BMD diagram, and this is A and this is B. Okay friends, so in this just 3 steps we can find a bending moment and shear force diagram. So hope you get something from this video and learn this draw and calculating of shear and bending moment diagram. If you like, subscribe my channel, hit bell button and share a link with your friends. See you inshallah. Have a nice time.